Okay, we are recording, and this is Friday, February 9th. Thank you. We are looking at lesson 7-1 for the geometry class, ratios and proportions. Okay, you have done this for a long time, but here we go. I have some classmates here today. Many are gone, but here are some of them. Oh, and they're sideways. Oh, and there's James. Okay. And there's Tyler, and I guess I should have let you all sit back there because now we can't see the rest of you. It's sideways. And there I have and there's finally one. Oh, right there. Okay. Let's get back on track here. Sorry. It's kind of blurry because it's meant for this paper. Okay, hopefully that doesn't make anybody sick. From the dizziness, not from who you see. Okay. Now, you have solved problems by writing and solving equations. Now we're going to write ratios and write and solve proportions. And here's an example of why. The aspect of ratio of a television or computer screen is the screen's width divided by its height. A standard television screen has an aspect ratio of 4/3 or 4:3, while a high-definition television screen, HDTV, has an aspect ratio of 16:9 with a much clearer view with that higher ratio. Okay, so here we go. Some new words, really not all new, but some of them are new. Ratio, extended ratios, proportions, extremes, means, and cross products. Some of those words you may remember from Algebra 1, some you might not. But here we go. We're going to write and use ratios. A ratio is a comparison of two quantities using division. The ratio of quantities A and B can be expressed as A to B, A colon B, or A with the fraction bar B, where B does not equal 0. Ratios are usually expressed in simplest form. So the aspect ratio, 32:18, and 16:9 are equivalent, because if we divided 32 by 2, we would get 16, and 18 by 2, we would get 9. So it means the same thing. Everybody okay with that? Just like an equivalent fraction. Okay, so 32 over 18 divided by 2, 16/9. So either way, you write it this way, or this way. It all means the same thing. Now, we read ratios with the word 2 in between, 16:9. 32:18, 16:9 here. So we have to be careful to know what we're talking about when we're looking at an example. Okay, a baseball player's batting average is his ratio of the number of base hits to the number of at-bats, not including walks. Minnesota Twins' Joe Mauer, I think is how you say that, had the highest batting average in Major League Baseball in 2006. If he had had 521 official at-bats and 181 hits, find his batting average. Okay, so now it said baseball playing's batting average is the ratio of the number of base hits, to the number of at-bats. So base hits to the number of at-bats. So 181 over 521. And simplifying that, to take that down to a 1 on the bottom, we would just actually divide that on the calculator, and you would get 0.347. Have you guys ever heard of a baseball player's batting average? Well, that's where that comes from. So it is number of hits divided by at-bats. So up to bat. So Joe Mauer's batting average was 0.347. Okay. Oops, in doing this, I showed the answer. Okay. So let's look at, and somebody help me out here. I'm going to try to hide this a little. In Logan's High School, there are 190 teachers and 2,650 students. What is the approximate student-to-teacher ratio at this school? So basically, how many students to each teacher? How would we find that, do you think? What's going to go on the top and what's going to go on the bottom? Go ahead, Jonathan.
Teachers are going to go on the top and students on the bottom.
Okay, so what do you get? You guys have your calculators out? You can give an approximation to the nearest tenth is fine. Do you just know it?
Nope.
James? Okay, no one has their calculator? Oh, we have Tyler. He's a faithful soul. Just round to the nearest tenth is fine.
0.1.
Did you do students to teachers?
Oh, I thought you said teachers.
Well, we're doing a student, if you right here, student to teacher ratio.
Oh, I did say.
Oh, sorry.
Around 14.
Around 14. Okay, and that's fine. Now, the way they wrote it is 14 to 1. Okay? So, oh, I need a pencil. Could you run and get me a pencil or a pen? I don't care. So, the way that they did it is they set up the colon ratio, and then you want to get it to be 1 to one teacher. About how many students are there to every one teacher? Okay, so it is 2,650 to 190. Okay, so this is the way they set it up, and then divided it. Well, first off, you could cancel those out, and then you could get 265 to 19. And then 19 is prime. I don't think 265 divides by 19, but we would do it anyway. And I've got my calculator. I can do that. So if we turn on our handy-dandy little calculator and do, now I can't remember, 265. 265 divided by 19. So it's almost 14. So they just rounded it to 14. So they said approximately or about 14 to 1. Does everybody understand that? Okay, good. Now, let's continue. Extended ratios can be used to compare 3 or more quantities. The expression A to B to C, this is an extended ratio because it's more than just 2, okay? Okay. Means that the ratio of the first 2 quantities, A and B, and the ratio of the last 2 quantities, B to C, and the ratio of the first and last quantities, A to C, are all equivalent ratios, is what that's saying, okay? All right, now let's see an example of that. And I'll have to move the book over a little bit here so you can see it. Hey, there's a nice smudge. Okay. So there we are. The ratio of the measures of the angles in a triangle is 3 to 4 to 5. Find the measures of the angles. Okay, 3 to 4, I could write, so the first 2, the last 2, and the first and last are all equivalent measures. So just as the ratio 3 to 4, or 3 to 4 this way, is equivalent to 3x to 4x, or 3x to 4x, the extended ratio 3 to 4 to 5 can be written as 3x to 4x to 5x. Okay, sketch and label the angle measures of the triangle. Then write and solve an equation to find the value of x. So, we know the ratios are going to be the same for the angles from each to each one. So, to find out what they actually are, we have some common factor that had been divided out to put it in simplest form. Well, they've drawn a triangle, and one is 3x, one is 4x, and one is 5x. And we know about every triangle adds up to be what? 180, that is correct. So if we add up the angle measures, we don't know what the actual angle measures are until we find out what factor they were multiplied by. We know they can't be 3, 4, and 5. Why not? The ratio is, but not the actual measures. Why can't they be 3 degrees, 4 degrees, and 5 degrees? That obviously does not add up to be 180, right? Okay, so in doing so, we can get 3 plus 4 plus 5, that's going to be 12x equals 180. Divide by 12 and you get 15. So the factor is 15. So if we put that back into our measures, 3 times 15, that's 45. 4 times 15, which is 60, and 5 times 15, which is 75. So our actual angles are 45, 60, and 75. Everybody good to go with that? And they add up to be a nice 180. Okay. All right, now let's look at the next one. I have to cover it too because we have the book here with that answers in it. Okay, in a triangle, the ratio of the measures in this case is 2 to 2 to 3. And the perimeter is 392 inches. Find the length of the largest side of the triangle. They only want one side. So if you look at that, it's 2 to 2 to 3. Okay? Now, what does that tell you? Can anybody tell me something? This triangle is going to be what type of triangle? Yeah.
Isosceles.
It's going to be an isosceles because 2 of the sides have the same number right there. Okay? So there's some factor that we're going to multiply all 3 of those parts of that ratio by to get the actual lengths. Okay, now these are not angles, so we can't add those up to be 180, but we can add them up to be 392 because that's the perimeter. Okay? So go ahead and take a minute and it's kind of set up like this one up here, except it's not 180, it is 392. Okay? Go ahead and do that on a piece of scrap paper or a board or whatever you want to do it on. Sure. There's one right on my desk right there. 2 on my desk, actually. Absolutely. Those of you who are at home, you can go ahead and do this while we're doing it. Yes, sir?
Would it be 168?
It would be 168. Okay? I'm going to go ahead and show you how to get there, or James can explain it to us. Go ahead, James.
Well, I don't know what I did.
Okay. Well, you have these ratios, 2 to 2 to 3. We know they're all because that doesn't add up to be 392, does it? So we know since they're a consistent ratio there, then we know that they're all going to be multiplied by some factor, the same factor, and then added up to be 392. So 2x plus 2x plus 3x equals 392. Then solve for x. So 7x equals 392, x equals 56. But x is not our what they're asking for, right? They're asking for the largest side. Well, 3x would be the largest side, right? So we would take 3 times 56, and that should equal 168. Oop, that's kind of shiny on there. Okay, so that should equal 168. And don't forget to label inches. Okay, great. Now, let's go down and talk about the next thing. Let's look over at our little math tip right here, reading math. Proportion. When a proportion is written using colons, it is read using the word 2 for the colon, not the word colon. For example, 2 to 3 is read 2 to 3 even when we have the colon. The means are the inside numbers and the extremes are the outside numbers. Okay, so if we have something that is written like this, right here, I don't know why that looks a little blurry to me. Let me try to refocus again. Well, okay. So we have 2 to 3 equals 6 to 9. And it says the means, and this is a vocabulary word, means are the inside numbers. So they're right here. Those are the means. And then the outside two are called the extremes. Well, I did it underneath, they did it above, but oh well. Okay, means and extremes. Okay, so let's look at this and see what we can do with means and extremes. Okay, an equation using two ratios are equal is called a proportion. So a ratio is one by itself, but if you have two that are equal to each other, that's called a proportion. In the proportion A to B equals C to D, the numbers A and D are called the extremes. Okay, so the extremes are upper left, lower right. The means are lower left, upper right. Okay, so extremes and then means. Okay, now let's go down, and the product of the extremes, A times D, upper left, lower right, and the product of the means, lower left, upper right, are called cross products. And that's something you've been doing for many years, so that should not be a shocker. Okay, now, so when we have something like this, and these are the words, hopefully you're putting this into your foldable or your cards to use on a test. If 4/10 equals 6/15, if that's true, then the extremes, 4 times 15, needs to equal 10 times 6. Does that equal? What's 4 times 15, somebody?
60.
60. What's 10 times 6?
60.
Also 60. So that would make that true. So you can check to see if two proportions or fractions even are equal by multiplying the extremes and the means, and that can help you know if it doesn't come out equal, then you know your fraction or your proportion is not equal either. Okay, so right here, and it says the converse of cross product property is also true. If AD equals BC, B cannot be 0, D cannot be 0. That would make your fractions undefined, right? Your proportion, your ratios of your proportion. Then A over B equals C to D. That is A to B and C to D form a proportion. So that's what I was just saying. That's really wordy, but if you cross multiply and that's equal, then you have proportions. You have their equal proportions or equal ratios. You can use cross product property to solve a proportion problems. Okay, let's look on to the next page here, Pahina. And here we are. Now, let's look at this study tip. Perseverance. Example 3b, and we're going to get to that in a minute, could also be solved by multiplying each side of the equation by 10, the least common denominator, to get rid of the fractions, if you like to do that first. So if we had x plus 3 over 2 equals 4x over 5, and we cross multiplied the extremes and the means, we would get 5 times x, the quantity x plus 3, not just times the x, right? Quantity x plus 3, and 2 times 4x. Then distribute and simplify, and you get x equals 5. Now, if you multiplied by 10 on both sides, you would go straight to, and that's what they did really, because that 10 becomes a 5, and that becomes a 1, which you end up cross multiplying anyway, so I'm not really sure how much time that's going to save you, but it is a method. Okay, let's move over here. So here, solve each proportion. So we have 6 is to x as 21 is to 31.5. Now, when we have a missing variable, we can solve, correct?
Yes.
Thank you. So we're going to cross multiply the extremes, upper left, lower right. 6 times 31.5 equals lower left to upper right, the means. So that's x times 21. Okay, 6 times 31.5 is 189. Divide both sides by 29 and x equals 9. Now, here's the one they were talking about which ends up being the same way, which I've already kind of walked through. But cross multiply, and don't forget you're multiplying by a quantity here. So you distribute that quantity, subtract 5x from both sides, so 15 equals 3x, and then x equals 5. All right, so let's do 3c, okay? Go ahead and do 3c on your paper, and then I will do it on this paper. Make sure you're coming up with the answer that they do. So it is 7 to z minus 1 equals 9 to z plus 4. All right, so here we go. Make sure you're getting the correct thing. I'm going to go ahead and do it on the paper to save us some time. So 7 times z plus 4 equals 9 times z minus 1. Okay, we're going to distribute, and we're going to get 7z plus 28 equals 9z minus 9. All right, now we can bring the z's over here. It doesn't really matter which side you go to, but so we're going to subtract 7z from both sides, and we're going to get 2z over here. We're going to add 9 to both sides and get 37 over here. So z is going to be what, folks? What is half of 37? 18 and a half, or 18.5. Either way you want to write it, it's totally fine. Did everybody get 18 and a half? If you did not, I would love to help you out, okay? Look up here at my work, and I will walk through the steps in case you did not get it correct. Grant, did you get 18 and a half? What did you get?
I got 19. I think I might have screwed up on my work somewhere.
Okay. They just left it in the book right here, if you can see, 37 over 2, which is fine. You can divide both sides by 2 and get 37 over 2, which is equivalent to 18 and a half. Okay. Oh, you did? Okay, good. All right. Okay. All right, let's move on just a little bit more here. And